arithmetic and geometric sequences, identifying and writing an explicit rule. The sequences below are either arithmetic or geometric. For each sequence, determine whether it is arithmetic or geometric, and write the formula for the nth term, a sub n, of that sequence. Alright, so basically what we're asked here to do is write an explicit formula in sequence notation because they ask us for a sub n here. But before I can write any formulas, I need to decide, is it arithmetic or geometric? So we're going to start with this first sequence here, and I need to decide how to get from 8 to 16. Now I could add 8 or I could multiply by 2, so I need to see what pattern is happening. To get from 16 to 32, I could add 16 or multiply by 2. So the common factor that I see here is multiplying by 2 every time. Now because we're multiplying, that makes it a geometric sequence. So the answer for this part is geometric. Now in order to write an nth term formula or an explicit formula, I need to know my starting value, I need to know my common ratio. So here I can see that my starting value is 8 and I know my common ratio is 2 because I multiply by 2 every time. So my a sub n is going to equal my starting value 8 times my common ratio, but I'm not just going to multiply my common ratio once. I'm going to have to multiply it a couple times in order to jump to a term in the sequence. So it's going to be times 2 to the n minus 1. Now if you use your notes, you can just see that automatically, that a sub n equals the starting value times the ratio to the n minus 1. But to help understand where this comes from, if we think about this sequence here, to get from 8 to 16, I multiply by 2 once. To get from 8 to 32, to start at the first one and jump to a different term, I'm going to multiply it by 2 twice. The next term would be 64, which would be 8 multiplied by 2 3 times. So what I see here is this repeated multiplication, which we represent with an exponent. So 8 times 2 times 2 times 2 gives me the fourth term. So I multiplied 2 3 times, so it's n minus 1, because if I'm trying to find the fourth term, I multiply it by 1 less than the term number. Now, if that didn't make a ton of sense to you, that's okay. Just use your notes and get used to that pattern. It will be the same for every geometric sequence. Now, to do the second, I need to, again, find my pattern. So I can see to get from 7 to 21, I could add 4. And to get from 21 to 25, I could also add 4. So because we're adding, I know that this is an arithmetic sequence. And I know that my common difference is 4 because I'm adding 4 every time. Now, to write my explicit formula, I'm going to take, to find any term value, a sub n, I'm going to take my starting value, which is 17, and I'm going to add the common difference, which is 4. I almost wrote D. Let me try that again. So a sub n is going to equal my starting value plus my common difference, which is 4, times n minus 1. Now you could just put that in and it would be fine, or if you want, you can simplify it. So 17 plus, and I could distribute this, so I get 4n minus 4, which is 4n plus 13. I could also put a sub n equals 4n plus 13. So this one right here would be totally acceptable, or this one right here would also be acceptable. Now, if you are curious to see how we can see this pattern here, is that we start with 17 and we go to 21, 25, 29, and so on. Okay, to get from 17 to 21, I add 4. To get from 17 to 25, it's adding 4 twice. To get from 17 to 29, it's adding 4 3 times. The way we represent repeated addition is by this multiplication here. So 17 plus 4 that many times will give you the term in the sequence. And that's it.